Okay, question 7. First part here is to define internal energy. Carers needed here to get the full 2 marks. First part, you need to mention the sum or total of the kinetic energy and the potential energy. But you then need to, for the second mark, bring in the fact that it's about the kinetic energy and potential energy of the atoms, molecules, or particles of the substance. Part B is talking about differences between ideal gases and real gases. So the differences. State how internal energy of an ideal gas is different to that of a real gas. Well, with a real gas there is actually attraction between the molecules, and that doesn't take place with an ideal gas. So best bringing in here the idea that the potential energy of an ideal gas is 0 or negligible, and that's because we have to assume that there is no attraction whatsoever once a gas becomes a gas. Part 2 of this one now is going to get you to calculate the temperature of a gas in a cylinder under certain conditions. And it does say here very carefully in Kelvin as well, so that is an important aspect of this question. So this one's going to ask you to use PV equals nRT, the ideal gas equation. There are no marks for stating the ideal gas equation in this form. However, if you do rearrange it into the form of T equals PV over nR, you will be given 1 mark. Or if you just substitute the numbers in that form, you'll get the mark as well. Either one will give you 1 mark. Put the numbers in. Be careful that you have the numbers all in the base units: pressure, volume, number of moles, and the ideal gas constant. So be careful of the units you're using. If you get the units right in there, the answer will come out to be 7.7 Kelvin. So it's important that you are stated in Kelvin. If you put it into degrees Celsius, you will get the mark, but why have you done that? Okay, final part here. The kinetic theory of ideal gases is one example of a scientific model. 2 reasons why scientists find such models useful. So why are models useful? Okay, number of different possibilities here. You can mention about prediction, how they're used to hypothesize or lead to further theories, or to help explain things, help with understanding, or to visualize. They're all similar things. Simulation, or to simplify and approximate. All sensible reasons why we use models in physics.